Hi everyone, welcome to LearnNCode. In the last session, we have executed C programs using Visual Studio Code for the implementation of increment and decrement operators, after that assignment operators. In today's class, we are going to discuss conditional operators and special operators. So first, let us have a discussion on conditional operators. The syntax of the conditional operator is like this. So the syntax can be written as expression 1 question mark expression 2 colon expression 3 and finally semicolon. So this syntax can be read from right to left. So question mark is similar to if expression 1 is true, then execute expression 2. Else colon means otherwise, or we can say else execute expression 3. This is the syntax of the conditional operator. Now, conditional operator is also known as ternary operator. What is ternary operator? As we discussed earlier, the operator which takes three operands. Three operands is called ternary operator. Already we have seen previously unary operators, binary operators. Now we are talking about ternary. Unary means only one operand. If the operator operates on only one operand, that is called unary. If the operator operates on two operands, that is called binary. If you take three operands, then it is called ternary operator. So if you observe the syntax, we have expression 1, expression 2, expression 3. Expression 1 is the first operand, expression 2 is the second operand, expression 3 is the third operand. So there are three operands, and the operator we are using is question mark and colon. So it is similar to if else. So in the coming classes, we will see if else statement. So question mark colon is same as if else. So this is a simple explanation of conditional operator. So after that, we will see programs after completion of the special operators. Now let us move to special operators. Now, how many types of special operators are there? Special operators, mainly in this, we are talking about sizeof operator. And second one is we use this, we call it as ampersand. But in what sense we are talking about this as special operator means address operator. We also call it as address operator. Third one is we use star. This is, we call it as indirection operator, or we call it as dereferencing operator. Dereferencing operator. Now after this, we also use dot operator. It is read as dot, or sometimes we call it as period operator. Now after this, we also use this arrow. This is used to refer pointer to member operator. Pointer to member operator. And after this, we also discuss comma operator. Comma operator. So basically, in special operators, we are going to talk about sizeof and address operator and indirection operator, dot operator, pointer to member operator, comma operator. See, the operators ampersand, star, dot, and arrow, these are mainly discussed while we discuss the concept of pointers. Okay, but roughly I will explain what is this, what are these operators, but in depth we are going to see in the chapter pointers. Now, first let us have a discussion on the special operator sizeof. What is sizeof? See here, the operator sizeof used to find the size of a particular data type. Why we are using this? To find the size of a particular built-in data type. Mainly we are taking built-in data type. Built-in data types are also nothing but primary data types or basic data types. So what is the syntax of this? The syntax is simply just you write size of, don't give any space, size of, in bracket mention the data type. For example, if you say size of int, it gives 2 bytes. So depending upon the machine, it gives either 2 bytes or 4 bytes. But generally, integer takes 2 bytes, float takes 4 bytes, double takes 8 bytes. So the size, if you want to know, you can use directly size of operator in programming. After this, so we are going to discuss this operator ampersand. See, this single ampersand will act as unary operator as well as second one is binary operator. When it acts as a binary operator, then it is nothing but bitwise AND. When it operates on only one operand, that we call it as address operator. We are referring to the address of a variable. As we discussed in the earlier classes, whenever we declare a variable, the variable is going to take some amount of memory and also a particular memory location, and it's every memory location is having its own address that already we discussed earlier. So this ampersand, when it acts as unary, it refers to address operator. So generally, we use the concept of pointer variables to store the address. So we will discuss in depth while we discuss pointers. Now, binary operator, for example, if I say A and B, in this case, it is acting as the bitwise AND. Already we discussed bitwise AND. So here, ampersand means not bitwise AND, we are talking in the sense of address operator. So that is called special. Now, third one, we use the dot operator, right? This dot operator mainly used in the concept of structures that we will discuss later. After that, we use arrow. This is also used in the concept of pointers that we will discuss in the coming classes. Now, the only thing is we have to discuss about fifth one, indirection operator. This is also discussed in the while we discuss pointers. The only thing we have to discuss in today's class is mainly about comma operator. Comma operator. Remember that the comma operator mainly works in two ways. It acts as separator, and second one, it also acts as operator. It is acting as both separator as well as operator. For example, if I say like this, integer a comma b comma c comma d, the meaning of this is it is similar to integer a semicolon, in the next line integer b semicolon, integer c, integer d. So instead of writing in separate lines like this, we are using commas. So here the comma is acting as a separator. It is acting as separator, right? Now, when it is going to act as operator, for example, here I am writing like this, integer a, and here I am writing a equals to 3 comma 4 comma 5. Integer a and a equals to 3 comma 4 comma 5. So if you observe this statement, first we are storing 3 is there, next to 4, next to 5. Here in this statement, we have the operator, assignment operator, and also comma operator. See, while we discuss the concept of associativity or precedence, so assignment operator is having higher precedence compared to comma operator. That means assignment operator is evaluated first, next comma operator is evaluated. Now, in this case, what happened? First, assignment operator is equals to is performed. 3 is assigned to A. Now, A value how much? 3. After that, it moves to 4 and 5, but 4, 5 are not stored in the A. They are simply rejected. So, finally, it stores the value of A as 3. If you print A, we are going to get 3. This is the concept of comma operator, right? So, more examples we will see like this. If I say integer A equals to, for example, 4 comma 5 6, if you say like this, So the meaning of the above statement similarly looks like this: integer a equals to 4, comma int 5, comma int 6. The meaning of the above this statement can be written as this. But here you can't say integer 5, integer 6. If you write the statement like this, it gives error. Don't write like this. This is one important thing you should know. Now, if I write the statement like this, integer a, and if I write a equals to in parentheses 3 comma 4 comma 5 comma 6, so what is the output of the variable a, or what is the value of a? In this case, the a value is 6. Why 6? Why? Because when we have parentheses, first you have to evaluate the values which are available in the expression parentheses. We are taking 3, next to 4, next to 5. Finally, this 6 is assigned to a. So first we are using the importance, we are giving the importance to the parentheses. Once we complete the parentheses, finally we are storing the last value into a. So when we don't have parentheses, a value became 3. When we have parentheses, the a value becomes 6. So this is the specialty of comma operator. Not only this, for example, if I write like this using comma operator, for example, I'm writing this printf percentage s slash n double quotes close comma, in double quotes I'm writing hello, comma, if I write 5, what is the output of this? If I write the statement printf percentage s hello comma 5. So in this case, first the parenthesis part is executed. Here this part is evaluated and it doesn't return anything. And finally it gives the value 5. Okay, but before 5, you are going to get the output as hello. This is evaluated, but nothing is returned, but it prints hello. Next, it prints 5. This is the output of the above printf statement using comma operator. So this is a simple discussion about comma operator. We will also see another example. For example, here you write integer a comma b comma c comma d. Next, what I'm writing is I'm writing like this: d equals to a equals to 1, b equals to 2, c equals to 3, and d equals to a plus b plus c. So in this case, you are going to get the d value as 6. Why? First, the expression within the parenthesis is executed. That means a equals to 1, b equals to 2, c equals to 3. Next, d equals to a means 1 plus 2 plus 3. So finally, you are getting d equals to 6. So these are some examples using comma operators. After this, we will see C programs on conditional operator as well as comma operators using Visual Studio Code. So now let us see C programs using conditional operator. Now we are going to write a C program for conditional operators. Program using, so better to write in a small lowercase, program to implement conditional operator. Conditional operator, right? We know hash include stdio dot dash, this is common, you know that. Int main, into main, and here just I'm taking two variables, integer a comma b, right? Printf enter any two numbers slash n double quotes close. So now you read two numbers, scanf percentage d double quotes close comma ampersand a comma ampersand b, right? Now, so we are reading two numbers from the keyboard. Next, we are going to apply the conditional operator. Now, you write in parenthesis, just we have seen the syntax that First, if expression 1, then go to expression 2, otherwise go to expression 3. Now, I'm using first expression 1 like this, A is greater than B. So, here you type question mark. If A is greater than B, what I'm going to do is I'm going to write this printf percentage D is big. Percentage D is big. So, what is that percentage D value? A, right? Now, else means colon. Now, you write in the same statement or next statement, printf percentage D is big. So, in this case, you write comma B. Last, you put semicolon. Okay, so better to write slash n also. Here I'm writing slash n. Here also I'm writing slash n to move the cursor to the next line. And the last statement is return 0. Save the program. So here just I will explain each and every statement. So if you want to write comments in the middle, you can write comments. So execution is starts from the main. We are declaring two variables. This is the declaration part. And we are using printf statement to get the message on the screen that enter any two numbers. After that, by using scanf statement, we are reading two numbers into the variable A and B. If you want to read the values into A and B, we need to mention the address. So here ampersand means address. We are referring to the address of the memory location. So if I want to come to your house, I should know the address. In the similar way, if you want to read the values into the variables, you have to refer the address. Now in this statement, you read from right to left. If, that means question mark, if A is greater than B, then printf percentage D is big and we are printing A value as big. Otherwise, we are printing B as big. So let us have the execution part. Go to runner and click it. See, in the bottom, it is displaying that enter any two numbers. For example, I'm giving 5 as the A value, 6 as the B value. Now it is giving 6 is big, right? If I write another with another input, if I give A value as 6 and the B value as 5, it is giving 6 is big, right? So this is the output of the program using conditional operator. So like this, you can find out the whether the person is eligible for voting or not. Simple logic is you have to use question mark and colon. Colon is acting as else part. So here, instead of writing in the same line, you can also write printf in the next line like this. But here, don't type semicolon. Only you have to type colon. So we'll save it. Again, we will see the execution part. Right, again it is asking two numbers. For example, I'm giving the values 10 and I'm giving another value 12. So it is saying 12 is big. Here also we are getting the same output. So there is no restriction to write the printf statement in continuation. You can also go to the next line and you can write. This is a simple program using Visual Studio Code to implement conditional operator. So we will see more examples. So after completing the program for what is a comma operator. Now after this we are going to write the program using comma operator. That will see program to implement comma operator. Now here I'm taking some variables like integer, a comma, b comma, c comma, d. You can take any number of variables, right? Now I'm saying that a equals to 3 comma 4 comma 5. If I printf percentage d and if you print comma a, as we discussed, it is going to print 3. If you want to check it, you can check it. So if I execute this program, it is giving 3 here. You check it, right? Now if I write parenthesis, as I discussed, it gives 5. That we will see. Run it. So it is giving 5. You see this. Now, for example, if I write the same expression like this, in another sense, D, if I write D equals to, like we discussed, A equals to 1, comma, B equals to 2, comma, C equals to 3, comma, A plus, or I can say A equals to 1, B equals to 2, C equals to 3, and here I am writing D equals to A plus, B plus, C. We will see whether we are getting what type of output. Here you print D. We will check whether we are getting correct output or not. You see, we are getting 6. So in theoretical part, we have seen the same example, just I'm executing using Visual Studio Code, right? So another example we want to print is, for example, as we discussed, if I write printf %s, why we are using %s? To print string, right? So right side, I want to print string. What is the string we want to print? Hello, right? After that, we want to print a value 5. Now we will check it. What is the output it is going to give? Run it. You see here, it is giving hello. It is giving hello. Why it is giving hello? We are not printing anything, right? If I say integer a, if you say a equals to, like this, we will check whether what type of output we are going to give. Printf %d, comma a. Okay, now save. Once you run it, so you see hello, and we are getting 6. Hello, after that we are getting 6. Why 6? Can you guess? Why? Because we are hello. How many characters are there in hello? 1, 2, 3, 4, 5, and also it gives null character. This string is stored in the form of characters. So whenever you place the pointer here, it is giving 6. So even though you mention 5, it gives the output 6. So number of characters it is going to return. For example, I'm removing this. Now you run it. So it is giving hello 6. So though you don't say 5 value, 5 I have mentioned wrong. Why? Because hello is nothing but how many characters? 5 characters, but including null character, it is giving 6. So this is the working condition of the comma operator. In example, I said 5. Why? Because hello consists of 5 characters. There we have not counted null character. Actually, it gives the output 6. So this is a simple example using comma operators. So more C programs as well as theoretical part we will see in the next class. Thank you for watching.